Hi, my name is Ming. I'm an assistant professor at UC Riverside, and welcome to the beginner MassQL tutorial today. We'll take you through a little bit of the reasons why we want to use MassQL, what you can start representing in the language to start looking for patterns in mass spectrometry, and take you through a few short examples on how to do the most basic queries. I'm excited to have you with us, and let's get started. So whenever we measure molecules in mass spectrometry, each of these molecules imprint a pattern on the mass spectrometry data. It could be as simple as simply the monoisotopic peak, but it could be a lot more complicated with an isotopic pattern or a set of fragmentation peaks in the spectrum. So just as an example, here we might contain iron, which has a very distinctive isotopic pattern, or it could be bromine, which also has a distinct isotopic pattern, and two more examples showing distinct patterns in the MSMS. And so what MassQL tries to do is tries to capture and allow users to express these particular patterns they might be looking for. And so first, in order to express these, we need to make sure that it's easy for chemists to be able to read and write these patterns in MassQL, so it's understandable. Second, a second pillar of MassQL is that it's flexible, that it can express a wide variety of patterns that people might want to actually start looking at. Third is that it's scalable. We want to make sure that, right now people might be looking for patterns one by one spectrum at a time, which is incredibly slow. And so we want to make sure that if somebody takes the effort to express a pattern in a MassQL, they can search one file, 10 files, a whole project, or an entire repository of billions of compounds. And then fourth, we want it to be reusable. If MassQL can capture these patterns and the knowledge, we can share these with other lab mates, the whole community, so that people can reuse and reapply this knowledge to make new discoveries. And so just to give a few examples of some of the patterns that you can start expressing in the top left here, if there's a particular peak mass that you're interested in the MSMS or in the MS1, you can go look for it. In the top right, there can be losses from precursor in the MS2 that might be particularly interesting. Also, you can start looking for mass deltas between two peaks in a spectrum. And on the bottom right here, you can also start imprinting the intensity that you're looking for. So any combination of these four things, plus actually quite a bit more, but these are just the basics to get us going. And so one particular example that we have here that my collaborator Daniel Petros is interested in is albucidin. And so this is a peptidic natural product, and he knew that albucidins contain two peaks, 468 and 660 m/Z. And simply, you wanted to look for other spectra that had these two peaks in it. So simply, in highlighted in red here, the 468, and Danny was able to find that by writing this particular query, and he was also able to look for 660 by adding a conjunction to the query and expressing exactly what he wanted. And so that's a really simple example, and we'll take you through a few live examples against real data in the next video in this playlist. Stay tuned.